In this video, we're going to be looking at once we solve for the unknown variable in an algebraic equation, how do we read to get an understanding of what the equation is telling us? So, once we solve this equation, let's say this is our final equation that we're looking at. Speed is equal to distance divided by time. If I were to place 100 meters as a distance in a time of 10 seconds, my answer would be given as 10 meters per second. But what if either of these two variables changed? For instance, what if I decided to change the distance so that I wasn't traveling 100 meters, instead I was traveling 200 meters, but in the same amount of time? So when we take our speed and we take 200 meters divided by 10 seconds, we end up with 20 meters per second. So what happens is when I doubled my distance went from 100 meters to 200 meters. I also doubled my speed. My speed here was 10 meters per second. My speed is now 20 meters per second. What if we took and changed the distance so that it decreased? So instead of going from 100 meters to 200 meters, we went from the original 100 meters down to 50 meters. Now when the distance is cut in half, the speed is also cut in half. So distance cut in half, speed is also cut in half. It seems like what we found is whatever happens to the distance, here it was doubled, so was my speed. Here it was cut in half, so was my speed. Whatever happens to the distance also happens to the speed. Notice where the variable is of distance. The variable is on top of the equation. So when I'm solving for speed and a variable ends up on top of the equation, that means distance and speed are directly proportional, because whatever happened to distance also happened to the speed. We doubled the distance, we doubled the speed. We cut the distance in half, we also cut the speed in half. So if a variable, any variable, is on top of the equation, as distance is, then that variable to the variable that I solve for is going to be directly proportional. Whatever happens to that variable also happens to the variable that I solved for. What if we were not looking at distance, but instead looking at time? You can clearly see that time is on the bottom of the equation. So we start with our original 100 meters in 10 seconds to solve for 10 meters per second of the speed. But what if we change the time so that it increased to 20 seconds? So we doubled the time. In this instance, when we double the time, it actually cut our speed in half. It went from 10 meters per second down to 5 meters per second. So the time was doubled, the speed was cut in half. What happens if we what happens if we cut the time in half? So the time in half, 10 seconds to 5 seconds, it actually doubles the speed. So the time cut in half, the speed is doubled. In this instance, whatever's happening to the time, the opposite is happening. The inverse is happening to the speed. And that's due to time being on the bottom of the equation and not the top. So now when a variable is on the bottom of the equation, we say that it's inversely proportional. When we doubled the time, the speed was cut in half. When we halved the time, the speed was doubled. They're doing the inverse of each other. So as a summary, if your variable, when you solve for your variable, any variables that are on the top, they will be directly proportional to the variable you solve for. But when you solve for your variable, any variables on the bottom will be inversely proportional to the variable in which you solved. I hope this helps with understanding how to read equations.